Okay, so exponential order, yes or no? Thumbs up or thumbs down, what do we got? Yes or no for exponential order? Yes, no, 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 right? Your fraction ends up being infinity. So you are going to get a no for exponential order. So therefore, let's go back to the whiteboard. It erased, but we can do it here. I really wish that Zoom whiteboard would not erase when you went to breakout rooms. But what this tells me is the Laplace transform of e to the t squared does not exist. Laplace transform of e to the t squared does not exist because e to the t squared is not of exponential order. Okay, one more thing for today, and this is really, really cool. Uniqueness. So uniqueness of Laplace transforms. Uniqueness of Laplace transforms. Here's what it says. This goes both ways. It's a theorem going in two directions. So the first one is if little f of t equals little g of t, then capital F of s equals capital G of s. That one's not very interesting. We're going to put it down just to have it for a piece of information, but that one's not very interesting. If you start with two functions, you get two that are equal to each other when you do Laplace transforms. Bethany, who I can't see.
Was that theorem an if and only if? Like,
yeah, so that's the
that
second half of this, and that's the way more interesting part. This is boring, and you could get this from the definition, right? Because you're going to have two integrals with the same function in them, and obviously you're going to get the same answer. The reverse implication is way cooler. So if capital F of s equals capital G of s, then little f of t equals little g of t. That's the way.
I actually meant the less theorem.
Pardon?
I actually meant the less theorem.
Sorry, the inverse or exponential order. That's a good question. I don't know the answer. Hang on, I'm looking in my book. I don't have it as an if and only if in my notes, but let me see what the book says. One sec. Existence, more precisely than f of x exists. It's not written as an if and only if in the book, so that makes me think that it is not an if and only if theorem. Don't think the last one is. But I am not an expert in differential equations, and so I am not positive, but I would say probably not. The exponential order one is probably not an if and only if. But the uniqueness of Laplace transforms is an if and only if. So here's what this is saying to you. If you have a Laplace transform in the book and you find its inverse transform, you don't have to worry that I am going to say, your order's correct, your answer is correct, but here's another answer that's correct also. You know that you are only getting the single function that the Laplace transform comes from. So in other words, if I want to do the inverse transform of, I don't know, like 1 over s squared, there is only one answer. That's it. So there's only ever one answer to an inverse Laplace transform. The inverse is unique. That's what this theorem is saying. All right, let's stop sharing my screen so I can see all of you again. Okay, that is the end of the introductory material on Laplace transforms. That's it. So Monday, what we're going to do is say, why do we possibly care about these things in the context of differential equations? That's what we're getting into on Monday. Why are these things useful? Why have we been studying them for 3 days? What help do they give us in solving differential equations? We're going to go back to differential equations and figure out why Laplace transforms are useful. Everybody clear on where we're going, even if you don't understand it yet? Okay, that's Monday's plan. All right. Other questions on the stuff that we did today? Anybody else have questions on the stuff that we did today? All good? Okay, I will send out an email with the homework. I'll do that right now. And then I'll get videos posted in case anybody had connection issues or in case you want to go back and look. But thank you lots for all showing up to class this week. That's been huge. I really appreciate it. Hopefully it's working out as well for you as it is for me, which is sort of kind of halfway well if this is what we have to do. Don't forget that your homework is due at 2 today. My goal is to go into campus this weekend because I am essential for distance learning and print stuff off and get it graded, but no guarantees that it's going to come back by Monday. Last call. Anything else for questions? Okay, see you guys Monday. Have a good weekend.